Good morning, students. Okay, this is the continuation. Functions chapter continuation. Okay, so last small topics, last video ಅಲ್ಲಿ ಫಂಕ್ಷನ್ಸ್ ಟೈಪ್ಸ್ ಯಾವ ಥರ ಫಂಕ್ಷನ್ಸ್ ಇರ್ತವೆ, ಒನ್ ಫಂಕ್ಷನ್ ಯಾವುದು, ಮೆನಿ ಒನ್ ಫಂಕ್ಷನ್ ಯಾವುದು, ಆನ್ಟು ಫಂಕ್ಷನ್ ಯಾವುದು, ಇಂಟು ಫಂಕ್ಷನ್ ಯಾವುದು, ಆಮೇಲೆ ಒನ್ ಕರೆಸ್ಪಾಂಡೆನ್ಸ್ ಅಂದರೆ ಯಾವ ಥರ ಇರ್ತವೆ ಅಂತ ನಾವು ಜಸ್ಟ್ ನೋಡಿದ್ವಿ. ಇವಾಗ ಸ್ವಲ್ಪ ರೀಕ್ಯಾಪ್ ಮಾಡೋಣ. ಓಕೆ, ಟೈಪ್ ಆಫ್ ಫಂಕ್ಷನ್ಸ್ ಮೆಥಮೆಟಿಕಲ್ ಫಾಲೋ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ರೀಕ್ಯಾಪ್ ಮಾಡ್ಕೊಂಡು ನೆಕ್ಸ್ಟ್ ಸೊಲ್ಯೂಷನ್ಗೆ ಹೋಗೋಣ. ಓಕೆ, ಟೈಪ್ ಆಫ್ ಫಂಕ್ಷನ್ಸ್, types, okay, of functions. Okay, first one is, everyone you know, is one function. First one is one function. One function is the distinct domain, have distinct codomain. Okay, sir. Distinct exact distinct have. Okay, if x1 is not equal to x2 implies f of x1 not equal to f of x2, or if, okay sir, if x1 is equal to x2, then f of x1 is equal to f of x2. Okay, this is the first one condition. Okay, sir. Second one is many one condition. Okay, sir. Many one condition. Many one condition. Many to one. Okay, or to one condition. You can write. One minute, sir. Okay, sir. What is the minimum function? Okay, sir. If x1 belongs to f and x2 and y1 y2 also belongs to f. Okay, sir. Similarly you can tell, okay sir, f of x1 is equal to f of x2 not equal to, okay sir, we can write this one is equal to y1. Yes sir, this may be true. Okay, this is my own, okay sir, ನಾನು ಸ್ವಂತ ಐಡೆಂಟಿಫಿಕೇಶನ್ ಬರ್ತಾ ಇದ್ದೀನಿ. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಒನ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಟು ಡಿಫರೆಂಟ್ ಆಗಿಬಿಟ್ಟವೆ. Is it right, sir? Not. Okay, sir. x1 is not equal to x2 implies that, okay sir, f of x1 is equal to f of x2 is equal to y1. This is the condition for many one. Okay sir. Third one is onto. Onto, you know. Okay sir, this is very important. Okay sir, onto function. Okay sir, if x1 y1, okay sir, belongs to f and, okay sir, y is equal to f of x1 or x, okay sir, y is equal to f of x1 implies that, okay sir, implies that if condition completely apply, if implies that, okay sir, x is equal to another function g of y, where, okay sir, see, very this important, this belongs to here, this concept belongs to what is it, range or codomain, and this is the called Okay, this is called domain. Okay. And this condition is satisfied, then this is called onto function. Okay. If y is equal to f of x, then there should be a x is equal to y of x. Okay. See, this is x domain here, and y is the range. Okay, this is a reverse only. Yes. Okay, sir. Onto function. Next, into function is there. Okay, sir. Third one is into function. Okay, into. If it is not onto, then you call it into. Okay, sir. x1. Okay, sir. I am writing this one like this. x1, x2 belongs to x and y1, y2, y3 belongs to y. Okay, this is into function. Last one is there. Okay, sir. 1 correspondence. Okay, sir. 1 correspondence means it should be both. Okay, sir. 1. Okay, it should be both 1 and onto. Okay, sir. Just give the explanations. Okay, 1 and onto. It's called 1 corresponding function. Okay, sir. 1 is either this condition or this condition, and many one is okay, sir. 2 elements of domain have the same elements in codomain or range. Okay, sir. Onto function. If there is a y belongs to f of x, then x belongs to g of x. Okay, sir. F and y, f and g are different functions. Okay, sir. Different function means every image has a pre-image. Onto. Okay, sir. Into means okay, sir. Now this is the range is a proper subset of codomain. Okay, so here range is a proper subset of codomain, and 1 corresponds is both 1 and onto. Okay, sir. Let's see the examples right now. Okay, sir. Question number first is okay, sir. This is completely okay, sir. Indian school certificate. Okay. Indian school certificate class level mathematics. ಯಾವುದೇ ಕ್ವಶನ್ ಬರಲಿ ಅಲ್ಲಿ ಆ ಬುಕ್ ಕ್ವಶನ್ ಮಾತ್ರ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಓಕೆ ಸರ್, ನೀವು ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಸ್ ಮತ್ತೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಥವಾ ಓಕೆ ನೆಕ್ಸ್ಟ್ ರೌಂಡ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡೋಣ. ಬಸ್ ಬೇಸಿಕ್ ಅರ್ಥ ಆಗಲಿ. ಓಕೆ ಸರ್, ಬುಕ್ಸ್ ಕ್ವಶನ್ ಯಾಕಂದ್ರೆ ಆ ಬುಕ್ಸ್ಗೆ ಯಾವ ತರ ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಯಾವ ತರ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅನ್ನೋದನ್ನ ಹೆಲ್ಪ್ಗೋಸ್ಕರ ಈ ತರ ಮಾಡ್ತೀನಿ. ಓಕೆ ಸರ್, ಕ್ವಶನ್ ನಂಬರ್ 1, ದಿಸ್ ಇಸ್ ಅ ಫಂಕ್ಷನ್. ಓಕೆ, ಇದು ಫಂಕ್ಷನ್ ಹೌದಾ ಅಲ್ಲ, ದೆನ್ ರೈಟ್ ದಿ ಡೊಮೇನ್ ಅಂಡ್ ರೇಂಜ್. ಓಕೆ ಸರ್, what the first function? Okay, sir. All elements have different. Okay, sir. Different outputs. All different inputs have different outputs. Are distinct inputs have distinct outputs. Okay. Here, first one is 2, 3, 4. Okay, sir. Have different outputs. Yes or no? 1 and 2. Okay, sir. 2 has 1, 3 has 1, and 4 has 2. Okay, sir. This is domain and this is range. Yes, this is the function. Okay. R is the function. First one. Next, R is equal to 2, 3. R is equal to 2, 3. R is equal to 2, 3, 1 by 2, 0, 2, 7, and minus 4, 6. Minus 4, 6. Okay, sir. This is the function or not? Okay, sir. First write the domain and range. One thing you should remember, okay sir. Have 2 here and 2 here. Okay, just write it. Yes sir. First write the domain. Okay, and 2, 1 by 2, 2 and minus 4. Okay sir. Now, okay sir, repeating doubles. Okay, almost, and the range is equal to 3, 0, 7 and 6. Okay sir. Okay sir. Single element have 2 different images, so it's not a function. Okay sir. Not a function. Okay sir. Simply we can tell 2 and 3. Okay sir. And 2 and 7 does not belong to F. You can tell so. Okay sir. Third one is okay sir. Next question is, okay sir. Okay sir. A is a 1, 2, 3 set, and F, G are the all subsets of A cross A. Okay sir. Subsets of A cross A. Okay sir. This is called identity relation, identity function. You can also use same elements na are independent. Okay sir. Important. Okay sir. Idempotent. Okay sir. Then relation is called, and set is called. Okay sir. A union A is equal to equal. Okay sir. ID potent. ID potent. Okay sir. Like that here, identity function, identity relation. Okay. F, G, H are subsets of A plus B. They given, okay sir. They given different as F, G and H. First they ask the question, F is a 2 and 3 1 is a function or not? Okay sir. What is our condition for functioning? Okay sir. This is A and this is A. Okay sir. This is 1, 2, 3 and this is 1, 2, 3. Okay sir. What is our first condition? Okay sir. The X, okay, distinct element have distinct, okay sir. Which one? Images. Distinct elements of set A should have distinct element of set B, and this should be exhaustible. Okay sir. Here all elements should be utilized. Okay sir. We have 2 1, and 3 3, but one we do not have any combinations. Okay sir. Any images. Okay sir. One do not have any images. Any images. Okay sir. Hence it is not a, okay sir, because 1, okay sir, 1 1 or, okay sir, 1 2 or 1 3 does not belongs to F. Therefore F is not a function. Not a function. Okay sir. Condition, okay sir. Condition is, okay sir, what is the condition? Okay sir. Number of elements in X, okay sir, should be less than or equal number of elements in Y. Okay sir. Only for your identification, okay sir. Only for the theoretical purpose only I am writing. Okay sir. Means this element should be less than or equal to this one. Is it correct or not? Okay. Means set there will be 1 1 connection at least. Okay sir. Almost I have 1 1 connection. Okay. Okay sir. Elements of X should be utilized. Should be having at least one images. Second, G is 1 2 1 3 2 3 3 1. Second one, G is, okay sir, G is 1 2 1 3 2 3 3 1. 1 2 1 3 and 3 to 3 1. I think so. Okay. 1 2 1 3 2 3. Okay. 2 3 3 1. 2 3 3 1. Okay, sir. First thing is that we have one. Okay, we have one. We have two. We have three. Okay. Okay. So this is the maybe called function because all elements are utilized. Right domains. Okay. Domain is equal to okay 1 2 3. Okay. Then range is equal to okay sir 2 3 3 1. Okay. What is the condition? Okay sir. Two elements have different images. Okay, this one. Two elements of okay sir. Two elements of common elements. Okay sir. This is okay. This is which one? Okay sir. This is the minimum function. This is the minimum function. That's why this is G is a function. Okay sir. Our motto is should be. Okay sir. 1 2 and okay 1 3 and okay 1 3 2 3 2 3. I should write this only 2 3 1 and 3 1. Okay sir. Let's check this. Okay, why should we? No. This is not a function. I'm getting confused somewhere else. You will see this book and write here, okay? Stop getting confusion. One, 2, 1, 3 and 2 3 and 3 1. Okay sir, I wrote the same element, only my error is there, calculation, human error. The condition is okay sir, this is okay sir 1 2 and 1 3 not a function. Okay sir, one input should not have the two outputs. Is it true? No, not this. Okay sir. Not output. Okay sir. This is not possible. 1 3 and 2 3 not a form the function. Okay sir. And this is okay. This is okay. But these two are not function. Two elements of input should not have the common. Okay. Okay sir. Again I think so I'm getting confused though. Okay sir. This is the called function sir. This is the completely beginning of this confusion part only. Okay. Let's see. What is our condition? One okay sir. One input can have more than one images. But two input cannot have okay sir one images. See one this and this. Okay sir. I am writing correct, I am getting confused. 1 and 3. Okay sir. Should not belongs to G. Yes sir. We'll reset it. 1 and 1 3. Therefore G is not a function. Right. Third one, H is equal to 1 3 2 1 and 3 2. Okay sir. Let's see for H. Okay sir. What is 1 2 3 we have. Another one is this is A. This is also A. We have 3 2 have 3 1 2. Okay, sir. You have different elements. This is function. Okay, sir. This is the okay, sir. This diagram is very okay, sir. It makes easy. Okay. You are getting confused over the recognition of the functions. Just okay, sir. Follow the diagram. I think so better. S is equal to 1 to 2 to 3 1. S is equal to 1 to 2 to 3 1. Okay. 2 to 3 1. Okay, sir. Have the different numbers combinations. Let us see. Diagram. Okay, sir. This is a 1, 2, 3. This is also a 2. Okay, sir. There is 2 and 1. Okay, sir. 1 has 2, 2 has 2, 3 has 1. Okay, sir. This is also called function. Is it? Yes. It's also called function. Okay, sir. This is the one basic considering only. Next, we'll see this some x in x form questions. Okay, sir. X, okay, sir. X, y, some algebraic forms. Okay. Yes, sir. Next question is f is equal to x and mod of x such that x belongs to R. Okay, sir. They ask the question whether f is a function or not and trying to dominate. Okay, sir. Dominate the range. Okay, sir. Let's see. This is only form. Okay, sir. This is the form of x. You can write. Okay. This is equal to x mod of x such that x belongs to R. You can write, sir. Okay. F is equal to x and y. Okay. Like that. This is x and this is y. Okay. This is x and this is y. Okay, sir. Take any elements of x. Okay, sir. Any elements of x, it belongs to R also, and mod of x, it also belongs to R also. Correct, sir. Like that. Okay. If 2 belongs to R and minus 2 is equal to mod of is equal to 2 belongs to R. What is the value of mod, sir? Mod is almost greater. Is it greater than 0? Is it not equal to 0? Okay, sir. Value of mod is greater than or equal to. It depends on the condition. Okay, sir. Yes, sir. What is the condition? Okay, sir. Mod. Maybe okay, sir. If x is plus for positive value. Okay, sir. For negative value, mod x you can write. Okay, sir. Is minus x. Okay. For mod value, right, sir. If okay, sir, is the f of is the function such that okay, sir. Okay. X. Okay, if x is greater than 0 and minus x if x is less than 0. This is the condition. Okay. Let's see once again. Okay, sir. This is the completely positive value only. Okay, sir. So here we can write. Okay, sir. If I can write 2. Okay, sir. F of x is equal to mod x. Yes, you can write f of 2 is equal to mod of 2 is equal to 2 and f of minus 2. Okay, sir. Again minus 2 is equal to 2. Yeah. This is the mod. Yes, sir. Mod meaning. I can write minus 2 equal to 2 and 2 equal to 2. Write this. Okay. That's why it's the function. Okay, sir. F is a function. F is a function. Okay. And domain is R and range RF is equal to okay, sir, including 0 to infinity. Think so, right? This is the range is the 0 to infinite, only positive values only. Only, okay sir, this is completely positive value. Okay sir, this is the positive value. Positive value is only 0 to infinite, many values. Yes, then given here. Next question is gf is equal to 1 and 1 by n, and it is a positive integer. Next question is, the next question is, if g is equal to n and 1 by n and n belongs to a positive integer, check whether g is a function or not. Again, you can tell, okay sir, you can write g is equal to, okay sir, 1 and 1 by 1, you can write 2 and 1 by 2, you can write 3 and 1 by 3, okay sir. Or simply you can write g of x is equal to, okay sir, 1 by x. This is the function. Yes sir. So here 1, 1 by 2, 1 by 3, okay sir. Here, okay sir, 1, 2 and 3 belongs to R also, and okay sir, which one? 1, 1 by 2, 1 by 3 belongs also to R. Therefore, what the conclusion is, n belongs to R. Okay, the given function R or not? Okay sir, given function R only, condition R, okay sir, and 1 by n belongs to also R. Okay sir, that's why, okay sir, this is called function. This is called function. Just sir, I am writing the domain and codomain here. Just I am writing, okay sir, domain is, okay sir, domain is, okay sir, any positive, n is any positive integer, okay sir, any positive integer. I can write this R plus, you can write, okay sir, any positive integer they given, okay sir, they given any positive, again is any positive integer, but function defined in the R only, okay sir, you can write R plus, okay sir, not R plus, they given, okay, this is the Z plus, okay, the range is R, okay sir, R of f we can write is, okay, 1 by n, so okay, I am writing here only, okay, maximum 1, okay sir, 2, 0, I can write sir, yes, I can write 1 to 0, okay sir, for 1 I have 1, for 1 I have 1 is equal to 1, for 2 I have 1 by 2 means 0.5, for 3 we have 1 by 3, 0.9, for 10 I have 1 by 10 is equal to 0.1, okay sir, for 100 I have 0.01, but why for 10 to the power 10 I have 10 to the power minus 10, which is still is the greater than 0. This is the range. Okay, they are not mentioned, but only I am writing here only. Okay. Next question is example 5. Yes sir. Next question is, if f is a function from x to x square minus 2, x to x square minus 2, and x belongs to minus 2, minus 1, 0 and 2. Okay, the question is, list the elements of x and is f a function or not. Okay sir. Okay. Solution is, okay, first condition is we should list the elements, okay sir. What is our function? So I am writing this, okay, x square minus 2. Okay, sir. These are the inputs and this is the output. Okay, f of minus 2 is equal to minus 2 whole square minus 2 is equal to 4 minus 2 is equal to 2. Okay, sir. And f of minus 1 is equal to minus 1 whole square minus 2 is equal to, okay, sir, 1 minus 2 is equal to minus 1. And f of 0, third one, is equal to, okay, sir, 0 minus 2 is equal to minus 2. And f of 2 is equal to, okay, 2 square minus 2 is equal to 4 minus 2 is equal to 2. Okay, sir. They want list the elements, okay, sir, list the elements of x. This is the question. List the elements of f. Okay, sir. Therefore, f is, okay, sir, 2, 1, 2, minus 1, minus 2, and 2. Okay, should not write. Okay, sir. 4 minus 2, 4 minus 2. Is f is a function? Yes, sir. F is a function means, okay, sir, what is the domain? Okay, sir. See, for each element we have different output. Okay, sir. We can tell domain is equal to minus 2, 1, 0 and 2, and the range of f is equal to, okay, sir, again 2 minus 1 minus 2. Okay, sir. We have two elements for this one, okay, sir, this one is minus 1. For 0, we have minus 2. Yes, sir. This is the function completely because, okay, sir, because each element is there. We can write minus 2, okay, sir, minus 2 for we have 2, and minus 1 we have for minus 1, and for 0 we have 2, and for 2 we have 2. Yes, sir. 1 is minus 2. This is minus 2. Okay. For different also. One, because this is different, this is different, this is different, and this is different. We have different elements. Okay. F is a function. So next example 6 is there. Yes, the next question is, if f is a subset of z cross z and f is defined, f is equal to ab such that ab and a plus b belongs to z and f is a function. Okay, sir. What they given, I am writing, sir. Okay, sir. F of x is equal to some form, so any form they given, x is equal to what they given. Okay, sir. What I am writing is equal to y. Okay, sir. Usually what we write, yes, sir. Yes, y is equal to f of x. Okay, sir. Similarly, what we will write, f of, okay, ab is equal to a plus b. Yes, sir. This is the formation. Yes, sir. This is x and this is y. I can write, say, f of a is equal to a plus b. Okay, sir. We should choose the element such that, okay, sir, it should check whether each element, okay, sir, each element of E, A and B they are used to different inputs. Okay, sir. Different inputs should have either different inputs have a different outputs are common. So you have to check the conditions, sir. Okay, sir. First take the examples. A is equal to 0, B is equal to 2, and this becomes f into 0 into 2 becomes, okay, sir, f 0, 0, this becomes 0 plus 2 becomes 2. Again, takes any x equal to 0 and b equal to 3 different element. or b equal to 5. Again, f of 0 into 5 is equal to again f of 0. This is 0 plus 5. This becomes 5. Okay, sir. This indicates what? 0, 2 and 0, 5. Okay, sir. They are the different sets. Okay, sir. Order pairs. So this is never possible. Okay, sir. Because each element, okay, sir, domain, okay, sir, should not have more than one image in the codomain. Okay, sir. This should not happen. 0, 5. Okay, sir. 0, 5, 2, 5. Okay, sir. This is not defined as a set. Okay, sir. Not defined as a set. So this is not never going to be a function. Okay, sir. Example 7 is okay. Again same thing, sir. Last example is there. I will solve the. So one more example. Example 8 is there. Yes, sir. I am trying to solve only important examples. Okay, remaining is only you can. Okay, sir. Book ನೋಡ್ತಾ ಸರಿ ಡೀಪ್ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. ಅಲ್ಲಿ ಯಾವ್ದು ಅರ್ಥ ಆಗಲ್ಲ, ಯಾವ ಸ್ವಲ್ಪ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇರ್ತವೆ, ಯಾವ ಕ್ಲಿಷ್ಟ ಇರ್ತಾವಲ್ಲ ಅವ್ನು ಮಾತ್ರ ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಓಕೆ ಸರ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ ಇದೆ ಒಂದು. ದಟ್ಸ್ ಎಕ್ಸಾಂಪಲ್ 8. Okay, sir. Next very important. If okay, sir, A and B are two finite sets. Okay, sir. A and B are finite set. Okay, sir. Then number of elements in A is P and number of elements in B is equal to Q. Find the number of functions from A to B. Number of functions. Okay, sir. You should find n of f. Number of functions. Okay, sir. Just take, sir. Okay. Listen here. You have A. Okay, sir. You have 1, 2, 3 and B. Okay, sir. This is 4, 5, 6. Okay, sir. I am writing. Okay, sir. One can have 1, one can have 2, and one can have 3. Okay, sir. Similarly, 2 can have 4, 2 can have 5, 2 can have 6, and 3 can have 4, and 3 can have 5, and 3 can have 6. Okay, sir. Means one element has 3 function, and 2 has 3 function, and 3 has, okay, sir. Third element has again 3 function. Okay, sir. This is 3, this is 3, this is 3. Okay, sir. How many relations are there? Okay, sir. This is, okay, sir. 9 relations are there. Simply, okay, sir. For every element has 3, second has 3, and third element has 3. Okay, sir. Just it is, okay, sir. For the n numbers, for p elements, how many input you will have? Okay, sir. See, this is there are, okay, sir. Okay, sir. There are 3 to the power 3 elements. Similarly, for text, okay, 1, 2, 3. Take for the 4 elements. Okay, 4, 5, 6, 7. Okay, sir. For 1, we have 4. For 2, we have 4. For 5, okay, sir. For 3, we have 4. Okay, sir. This becomes 4 cube. Okay, sir. This becomes 4 cube. This is 3. This is 4. Similarly, sir, for 3 elements and 5 elements, you can write. Okay. Okay. For p elements, A 1, 2, 3 up to p. Okay, sir. Here I have some q elements. B have 1, 2 up to q elements. Okay, sir. Just listen carefully. Okay, sir. 1 can have 1, 2 up to q elements. Okay, sir. Similarly, 2 can have 1, 2, 3 up to q elements. Okay, sir. Similarly, 3 can have 1, 2, 3 up to q elements. Okay, sir. Infinite up to, okay, sir, up to p elements. So p can have 1, 2, 3 up to q elements. Okay, sir. This is the q numbers. This is 1q. This is the 2q. This is the third q. Okay, sir. In general, okay, sir. In general, I can write, okay, sir, q is the first q, okay, sir, into second, okay, sir, again third for third element, okay, sir, q up to, okay, sir. This is the p, na? Then for third, I write up to, okay, sir, p times, okay, sir, up to p times, okay, sir. This I can write, okay, sir, q into q up to, okay, sir, p times I can write is equal to q to the power p. How? Okay, sir, 2 into 2, we can 2 square, 2 into 2 into 2, we can type 3 square, 3 elements, 2 into 2 into 2 into 4, we can write 2 to 4 times, okay, sir. Number of times multiplication into the rise 4, okay, sir. We rise the that numbers, okay, sir. This is the total number of relations are q to the power p. What it indicates, sir? It indicates, okay, sir, n of b, okay, sir, to the power of n of a. Number of elements in b to the power of number of elements in, okay, sir, a. This also we can write, okay, sir. Number of relations, okay, sir, n of f. They are mentioned, I am writing also, sir, n of f. Number of, for, okay, sir, number of functions is equal to n of b is equal to n of a, or n of f is equal to q to the, okay, that's q to the power p. Okay, sir. This is the one theorem, you can call theorem or problem, okay, sir. Next question is, okay, sir. Next question is, okay, students. Next question is, if f is a function from f is a function from n to n, okay, sir, f of x is equal to 2x, now show that f is a 1 to 1 and not onto, okay, sir, 1 to 1. For the condition for 1 to 1, okay, sir. Okay, sir, if x1 is equal to x2, then implies f of x1 is equal to f of x2. This is the condition, okay, sir, to check the 1 1. Okay, sir. Just put the values. 2 of x1 is equal to 2 of x2. So 2 to the cancel, x1 is equal to x2. Therefore, f is 1 1. Okay, sir. What is the condition for onto? Okay, sir. At least y f of x or y has the one pre-image in y. Okay, sir. For onto, okay, let y is equal to 2x. Okay, sir. And y, okay, sir, belongs to n and x belongs to n. Okay, sir. This I am writing x is equal to 2 by, okay, sir, this is y by 2. Okay, sir. And this I am writing, this is equal to g of, okay, sir, g of x, g of y. Okay, sir. Here this y, okay, sir, for y belongs to n and y by 2 does not belongs to n. Okay, sir. The pre-image. So what you call? This is the pre-image. Okay, sir. Here, the pre-image. Okay, sir. Y by 2 not belongs to n. Therefore, f is not on 2. Okay, sir. So this means this is n and this is n. Okay, sir. We have 2 and we have, okay, sir, this is the x, this is 2x. For onto function, we should have, okay, sir, we should have, okay, sir, therefore, we should have elements such that, okay, sir, 2, okay, sir, any elements of 2, okay, we should take the, okay, sir, this is also n, okay, sir, for 2, we should have here 1 by 2, okay, sir, for 2 we have 2 by 2, okay, for 3, we have 3 by 2, this is not possible, okay, sir, this is for 3, okay, sir, for y is equal to 3, x becomes 3 by 2 and x is not belongs to n. This is the range for the onto function. For function g, respect to g, okay, sir, onto is not possible. Simply we can tell, okay, sir, this is the reciprocal, both 1 and 2, okay, it's by a reciprocal, that's why natural numbers does not have any reciprocal numbers, fraction numbers, that's why 2x is therefore f is not a onto function. Okay. Similarly, let's take the, okay, sir, next question is simple only. Okay. Similarly, they given instead of n, they given r. Okay, sir, function from r to r. Okay, sir. For one you can define. Okay, sir. You can define one. Let's check for the. Okay, sir. Okay. Y is equal to 2x implies x becomes y by 2. Okay, sir. X becomes 1 by 2. For both x and y belongs to r here. Okay, sir. Take the value of y, r. Okay, sir. This is the, okay, sir. This you can see in reverse it becomes y, this becomes x. In the positive, okay, sir, normal function becomes x and y. Okay, sir. For any elements of y, okay, sir. For any elements of y, for 2 we have, okay, sir. For 2 we have 2 by 2. For 3 we have 3 by 2. For 5 we have 5 by 2. Okay, sir. Both belongs to, okay, sir. This is very important. Y by 2 is belongs to r. Then that is a function from r to r. Okay, sir. That is a function from r to r. Okay, sir. In general, when exam or board exam, almost also in linear functions. Okay, sir. Linear functions. I am telling any first degree functions. Okay, sir. Any form of ax plus b. Okay, sir. F is equal to, okay, sir, ax plus b. Yes, sir. Okay, sir. Almost f is a function. Okay, sir. Maximum time. So almost we can tell this all times. F is a function, okay, sir, from r to r. Okay, sir. Because r has all natural, whole, and rational, irrational numbers set. That's why, okay, sir, any function in the form of a plus b, a plus or minus xb. Okay, sir. Let's check the last question. Okay, sir. Final question is if a function a is equal to if x is equal to r minus 2 and b is equal to r minus 1 and function defined here from a to b, that is equal to x plus 3 and divided by x minus 2. And for all x belongs to a, then show that f is a bijective. Okay, sir. Means you should show 1 1 and on to in respect to a and b. Okay, sir. For 1 1, what we will do? For 1 1, what we will do? Okay, sir. F of x1 is equal to f of x2. You have to show f of x1 is equal to f of x2. Yes, sir. Just put the value. Okay. X plus 3 divided by x1 minus 2 is equal to x2 plus 3 divided by x2 minus 2. Yes, sir. This particulation x1 plus 3 x2 minus 2 is equal to x2 plus 3 and x1 minus 2. This is the further, okay? Yes. Simplification. Simplification is x1 x2 yes, sir, minus 2x1 plus 3x2 minus 6 sir. Okay, sir. Is equal to x1 x2 minus 2x2 plus 3x1 minus 6. Okay, sir. Minus 6 minus cancel. x1 x1 get cancel. x1 x2 get cancel. Okay, sir. Now this becomes 2x1 plus 3x2 3x1 minus 2x2. Okay, sir. And this becomes 3. Okay, sir. Okay, sir. Plus 3 to get cancel. Oh, okay, get cancel or not? Somewhere we have some problems, sir. Okay, sir. This becomes, okay, sir. This x2 and this x1. Yeah. This becomes, okay, sir. 3x2 plus 2x2 is equal to 3x1 plus 2x1. Okay, sir. This becomes right side, this becomes left side, and this becomes 5x2 is equal to 5x1. This implies 5 get cancelled. x1 becomes x2. Therefore, f is 1, 1. First one is satisfied. Okay, sir. Let's see for the second condition, onto condition. Okay, sir. Next, onto for onto condition. Okay, sir. Onto condition means every 3 image. Okay, sir. Every image should have must 3 images. Okay, sir. What the condition they given? Y is equal to, okay, y is equal to they given x plus 3 and x minus 2. So, sir, y belongs to R. Okay, y belongs to R. Function from R minus 1. Here. For this condition, let us see. Just to find the formula for x. Okay, sir. Formula for x. Okay, sir. This becomes xy minus 2y. Okay, sir. Becomes x plus 3. Okay, sir. I am taking the xy minus x becomes 2y plus 3 and x y minus 1. Okay, sir. 2y plus 3. Okay, sir. X becomes 2y plus 3 divided by y minus 1. Okay, sir. Here x belongs to which one? B. Okay, sir. This one. Very important. If this is true, it will. Okay, sir. This belongs to R also. Okay, sir. That is the formula. So now it's the linear equation, first degree equation. So obviously we can tell this is the onto function. Okay, sir. Onto function. Let's check for the A, sir. Okay. Okay. For x belongs to A. What is A is R minus 2, na? A is equal to R minus Okay, sir, r minus 2. Okay, let's okay, sir. Let's put the value y is equal to 2. Okay, sir. Let's put the value y is equal to 2 here. Yes, sir. Our condition is one condition is this. If x belongs to, okay, sir, x is equal to 2. Okay, sir. Y they given except the element 2. Okay, sir. I will show you why it is. Okay, sir. If okay, sir, x equal to 2, 2y plus 3 becomes 2y minus 2. Okay, sir. 2y minus 2. This will become 2y will cancel and 3 becomes minus 2, which is not defined. That's why, sir. Okay, x belongs to, okay, sir, here, not okay, sir, here, x belongs to a. Therefore, another one, okay, sir. This is the form and you got. If you got this type of forms, here equations, obviously you can tell f is a your function is onto function. Okay, so we can prove f of is x is equal to, we can write, okay, sir, f of 2y plus 3 divided by which one? Y minus 1. Okay, sir. Just put the value of, okay, sir, here x plus 3 plus x minus 2. Here you can get 2y plus 3 divided by, okay, sir, and this get confused. Okay, so complex question again. Let's check. 2y plus 3 minus 2. Okay, sir, reverse order. Okay, y minus 1 plus 3 divided by y minus 1 minus 2. Okay, sir, what it becomes? 2y plus 6 divided by, okay, sir, 2y plus 1, and this becomes, okay, sir, y plus 2, this becomes y minus 3. Okay. Something is there, anything else? That is the answer, okay? Okay, sir, I was wrong actually. Just, okay, sir. This is the final to find out the one-on function. Okay, cross checking. They give cross checking by f of x is equal to f of what is 1? 2 of y. Okay, 2y plus 3 divided by y minus 1. Okay, sir. What is, so, sir, 2y plus 3 divided by y minus 1 equal to plus 3 divided by 2y plus 3 divided by y minus 1 minus 2. Okay, so after simplification, this becomes 2y plus 3 minus, okay, so plus 3y minus 3. This becomes, okay, sir, 2y plus 3 minus 2y minus plus 2. Is this is cancelled? This 2y plus 2 and this cancel, this becomes 5y divided by 5, this becomes y. Okay, so therefore y is equal to f of x. We got the same solution. Okay, sir, this is true means, okay, sir, this is true. This means, okay, sir, this is the pre-image. This is the image. Every y has its pre-image in the form of 2y plus 4, 3 by y minus 1. Okay, sir. Therefore, this is also onto function. Therefore, f is bijective. Okay, sir. This is not necessary to prove this one, sir. Okay. I don't know why they give up. Not just prove. Okay, sir. This is very important. Okay. This is relation and they given b is equal to r minus 1. Okay, sir. This is, okay, sir, belongs to r minus 1 b. Okay, sir. This becomes j and this becomes b. Function from a to b. Okay sir, in onto function our job is to, okay sir, deduce the formula in terms of y. Okay sir, already we have in terms of x. Okay sir, already have in terms of x. Okay sir, see y we have in terms of x. This for the general formula. If we found the formula x is equal to g of y, okay sir, g of y, then automatically this becomes onto function with some conditions, exceptions, -1, -2, some relations they will be given in the exam. Okay sir, this you prove, this becomes onto condition. Okay sir. Okay sir, I think so. This is the completion of the types of function and solution. Okay sir, types of function and examples based on the types of function. Okay sir, ಇಲ್ಲಿಗೆ ಮುಗಿಸ್ತಾ ಇದೆ ಅದು ಲಾಂಗ್ ವಿಡಿಯೋ ಆಗ್ತಾ ಇದೆ ಆಲ್ಮೋಸ್ಟ್. ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಓಕೆ ಸರ್ ರಿಯಲ್ ಫಂಕ್ಷನ್ ಸಮ್ ಫಂಡಮೆಂಟಲ್ ಓಕೆ ಸರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಂಕ್ಷನ್ಸ್ ಇದಾವೆ, ಅದು ಶುರು ಮಾಡೋಣ. ಓಕೆ ಸರ್, ದಿಸ್ ಇಸ್ ದ ಓಕೆ ಸರ್, ಯಾವುದೇ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಯಾವಾಗ ಆಯ್ತು ಅಂದ್ರೆ ಓಕೆ ಸರ್ ಟೆಲಿಗ್ರಾಮ್ ಗ್ರೂಪ್ ಇದೆ, ಅಂದ್ರೆ ಕಮೆಂಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ, ಕಮೆಂಟ್ ಮಾಡಿ. ಓಕೆ ಸರ್, ಕನ್ನಡ ಹುಡುಗರು ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ನೀವು ಬೇರೆ ಬೇರೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಕನ್ನಡದಲ್ಲಿ ನಾನು ನೋಡೋ ಪ್ರಕಾರ ಯಾವುದೋ ರೀತಿ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ, ಇದ್ರೂ ಕೂಡ ಸರ್ಚ್ ಮಾಡಿ ಓಕೆ ಸರ್ ನನಗೆ ಇಂಪ್ರೂವ್ ಮಾಡ್ಕೊಳಕ್ಕೆ ಕಮೆಂಟ್ ಮಾಡಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ವಾಚಿಂಗ್.